Okay. Hi. Lots of love for you. Here's number 4 in the practice redox problems that we did in class. So here we go. So this first one is in acid, H2SO4. So actually, I'm going to cover this so I can actually write on the top. Alright, look at that. That's my origami skills from back in the day. Oh, look at this. Let's make it. It's a little bit too big. Meanwhile, you're wasting your poor time. Sorry about that. Look at that. Doesn't that look nice? All right. Anyway, here we go. First thing when you have a problem like this is that you gotta find the oxidation number. So oxygen is -2. Okay. 4 times -2 is -8. The total has to be -1, so this has to be +7. Just kidding. On the 6 there. Good. HSO4, this is -2 times 3, -6. The total has to be -1. Hydrogen is +1, so +1 plus what is equal to -1? So it's +4. Alright. Over here, oxygen, -2 times 4 is -8. The total has to be -2, so this has to be +6. And I highly recommend writing all the oxidation numbers on top of the number, circle it. And then here the ion is +2, so the oxidation number is the same. Alright. Now we have to figure out who is being oxidized and who is being reduced. So manganese, +7, goes from here to +2. So that is becoming more negative. So it's like adding electrons. So this is gaining electrons reduction. Okay, and if you didn't believe that, just think +7 plus what is equal to +2. Oh, why? It should be a -5. So in order to make this, you have to gain electrons, the negative things, to get to +2. Sulfur here goes from +4 to +6. That's losing electrons. So that is going to be our oxidation. Okay. Well, then you got to break apart each half reaction. Let's do the oxidation half reaction. Okay. HSO3. Do not forget the charge. HSO3 minus goes to SO4 2 minus. Remember the order. Everybody orders hotcakes. Here we do elements by adding elements, plus A, B, C, whatever. Oxygen via H2O, hydrogen via H+, charge via electrons. Okay, good. Elements balanced except for hydrogens and oxygens. Yes. Now oxygens, we have 4 here, 3 here. We need 1 H2O. Now we have 4 oxygens here, 4 there. Hydrogens, 1, 2, 3 hydrogens. Over here we need to add 3 H+. Now let's do the charge. +3 and -2, that is equal to +1. Here you go. This is equal to -1. To make this the same, all we can do is add electrons. So let's add 2 electrons, and that gives this a -2 plus 3, -2. That's going to be -1. Okay, so the charge is balanced left and right. Usually it'll be 0 on both sides, but in cases like this where you already have the ion without the cation, it just has to be the same. Okay. Now let's do the reduction, half reaction. And the reduction is, let's start out with MnO4 minus, do not forget the charge, goes to manganese 2+ ion. Okay. So here we go. So Mns are balanced. Good. Oxygens, 4 H4Os. So we are going to need 4 H2Os. Now we have 8 hydrogen ions. We're going to need 8 hydrogen ions. Okay. Looking good. Beautiful. Now let's do the charge. Oh, don't put that marker away yet. Why not change to blue? Charge. This right here is +2. And then over here we have 8+ here, and then we have -1, so that's going to be +7. So the charges aren't balanced. In order to do that, we can only add electrons. Let's add 5 electrons. And that'll give us a total charge of +2 on this side and +2 here. So they're all balanced. Now we have to combine these redox reactions in a way that cancels out the electrons given out. It has to be the same as the electrons going in. Well, this gives out 2, and this gives out 5. In order to, the only number that they can be the same is, that's right, 10. Yay, you got it right. So multiply everything here by what? 5, because that'll give this 10. And multiply everything here by what? Yeah, 2. It's like Dora. And the answer is right. Good job. All right, anyway, so let's multiply everything out. 5 H2Os. Look at that, psyched you out. Plus, again, 5 HSO3 minus, do not forget the charge, goes to 5 SO4 2 minus, plus 5 times 3 is 15 H plus 5 times 2 is 10 electrons. On this side we have 10 electrons plus 16 H pluses plus 2 times Mn. I mean, you alternatively could do all the math here, which is fine. I just do it this way just for the kids at home. And also because it looks neater. And if I make a mistake, it's easier to go back and figure out what happened if I don't mess up. So 2 Mn plus 8 H2O. So let's see if that looks good. 8, 2, 10, 16, 2, 5, 5, 5, 15, 10. Always double check, because you know, one little error is usually all it takes to mess up. So watch yourself. Well, I'm only saying that because I always mess up. All right, here we go. Out 10 electrons, in 10, cancels. That's the most important part. Okay. Next one here. Let's see, H2Os. We have 5 H2Os and 8 here, so we can cross this out. And this is going to be 3 H2Os. Okay. Nothing in here. This is a different molecule. MnO4 minus and Mn2 plus, different molecule. Oh, H pluses. We'll cancel this out, and we'll just put in 1. I write the 1 down because sometimes it's easy for me to lose it if I don't write a 1. All right, let's combine everything and see what happens. This is like after the battle and the fray. Let's see what happens when the dust clears. So 5 HSO3 minus plus 1 H plus 2 MnO4 minus goes to 5 SO4 2 minus plus 2 manganese. I heard manganese. It just sounds like so corny. 3 H2O. All right, now let's check the charge. 5 times -2 is -10. 2 times +2 is +4. That's a total of -6. Over here, 5 times -1 is -5. Just kidding. 5, just one of these, +1, and then 2 times that is, what is that? -2. So here we go, -5 plus 1, that's -4, -2, it's a total of -6. So the charges are balanced. Let's check the elements. 5 S's, 5 S's. 2 Mn, 2 Mn. Hydrogens, 10, 11, 6. Oh, did I do this right? Yeah, oh, sorry, 5 hydrogens plus 1, that's 6. 6 hydrogens, good. Oxygens, 15 oxygens plus 4 times 2 is 8. 15 plus 8, what is that, 13? and then 4, 5 times 4, oh, 2 times 4 is 8 oxygens. I gotta slow down. 4 times 2 is 8 oxygens plus 15 oxygens, and that is equal to, what is that? 23. Over here, there's 20 plus oxygens, 5 times 4, and 3 oxygens. 23 oxygens. So the oxygens are balanced. Everything's good. Yay! So now we'll give the Good Luck Cat a hamburger. Unless he's a vegetarian, then it's a garden burger. Good work.